To calculate out JSC, short circuit current, or open circuit voltage VOC, or to characterize the IV characteristic of a solar cell or of a panel, you see a panel is connected across a load, and in that an ammeter is being connected so as to measure out the current, and a voltmeter is connected across the load. So this way, so this load is having a variable resistance, so you can use a decayed resistance kind of thing, whereby you can just by varying the knob you can vary the resistance of that load. So you can see this resistance is varied from say R equal to 0 to R equal to infinite, from minimum to maximum. So from the resistance is varied from R equal to 0 to R equal to infinite. So let's take the case when R equal to 0. So if R equal to 0, this is for theoretically R equal to 0 we can consider, but in practically when we are connecting some wire that will have some resistance, some minimum resistance it will have. So let us consider it as a minimum resistance. So when R is minimum, the load resistance is minimum. So all the current will pass through it. Okay, so this condition will be like this. It's a short circuited because resistance is minimum. So it's become a short circuited, and all the current will pass through this, get short circuited, and then this ammeter will be reading out the maximum current, and that is known as short circuit current, just because we have R equal to minimum or R equal to 0. So this ampere reading, the ammeter reading will be your ISC. Okay, similar is the case when you vary the load and go to the reading, go to the resistance reading of maximum or R equal to infinite, say some giga ohms or something like that, in that range. Okay, then this voltmeter is connected across this this variable load or your load. So now the voltmeter is reading out I into R. So R is infinite, that means the voltage reading, the voltage drop across this load will be maximum, and that is known as open circuit voltage, because R equal to infinite means, or like high value of R means that this circuit has become directly open circuit, and R is high, so whatever value of I, this R is very high, so the value of voltage will be maximum, and that is VOC. Okay, so practically you can check it out. Practically you can make this circuit. You take your panel or solar cell, take the two terminals and connect one of the terminal to one of the ammeter. So one of the multimeter can act as a ammeter, other can act as a voltmeter, and then this ammeter, one of the terminal is connected to the resistance box, and the other terminal of resistance box connected to the panel itself. So this is a series connection of panel and ammeter and then resistance box, and then this voltmeter is connected directly across to the resistance box, and then you, by these knobs, you are varying the resistance, and then you are checking it out. When the resistance is minimum, the current is maximum. When the resistance is minimum, all the current is flowing through ammeter, so that current is maximum IC, and the voltage is 0 because R is minimum, R is 0, so voltage output will be 0. Okay, now when you are varying increasing the resistance, the I will be, say, some value I, you can practically see it when you make the circuit. The voltage will increase with the resistance value, as giga ohm or 10 giga ohm or like that you are increasing the resistance, voltage will increase, but the current will remain, say, very minimum. So now I think this what the physical meaning of open circuit current or open circuit voltage or short circuit current is being clear to you. So you can see when R equal to 0, V is 0 because I into R, so V is 0, and ISC is maximum, all the current is passing through, maximum current, and then as R you are increasing by varying this load, you are increasing the resistance, and then some mid value of these are coming, and then R equal to infinite, VOC voltage is maximum, so VOC is, and R equal to infinite, I is 0. Okay, so V voltage is increasing and current is decreasing. So if you plot out this curve, just plot out this curve, you will get point like this, where where your VOC is increasing and current is decreasing out with different loads, or with output impedance load, with load resistance. Okay, so this is the IV characteristic of solar cell, and you can see this point Where current is 0, this point is known as VOC, open circuit voltage, in this IV plot, and this point where the voltage is 0, this is short circuit current. So now I think what is the physical significance of open circuit voltage and short circuit current is clear.